Hi there, and welcome to the second edition of the SolidWorks suspension frame series that we're doing here. And in the first one, we talked about the F4 top assembly level, and in this one, we're going to talk about the how we built the front triangle in a little more detail. So let's jump right in here and get started. The way we build it is that the first feature we create is a geometry feature, and I'll bring that up here. This is the first feature in the tree, and this has the driving dimensions of the geometry in it, and we constrain all the remaining parts and components to this geometry. So you can look at this geometry over here. We'll close that out for now. There's a couple more assembly layout sketches. We have a main pivot location, a TT location, but you get the idea. You create sketches on a plane of your preference, and those sketches allow you to constrain the parts to. So how do we do that? Well, if we take a simple one, here we have the head tube. The head tube has three mates in it. The first one is the front plane of the head tube and the front plane of the assembly that have a coincident. The second one is the right plane of the head tube and the center line sketch of the head tube that have a coincident. And then last but not least, the final degree of freedom is removed by the origin of the head tube and the end point of the sketch. And that gives you a part that is now fully defined and can't move. And so basically all these parts get fully defined so they can't move, but as you'll notice, these parts have really nice miter cuts, and how do we go about those? We use in context features to create these cuts. So this top tube, for example, has two different configurations. One of them is an S formed that has no cuts, and then one of them references the assembly, and that has these cuts in it. So how do we create those cuts? We do it using surfacing features. So if I go to edit part, we have this folder here that says assembly cuts. The first feature that is of any use is the surface offset. All these features can be found on the surfacing toolbar. We create a zero offset surface that basically creates an identical surface to the ones that intersect with the tube. Once we have that feature in place, we can create the desirable miter cuts. So I'm going to roll this back for now. We're in that mitered stage right now. We just showed you that we have this surface offset feature. We created a zero offset of the seat tube and the head tube. And then what we use is the surface cut feature to nicely miter these tubes. One thing to note, the reason we use configurations to do this is that the surface cut feature that you're seeing here is only available at the part level. It's not available at the assembly level. So you cannot create these cuts just at the assembly level. You have to create these cuts at the part level. And if you want to use this top tube in multiple front triangles, the only way to keep track of this stuff would be with configurations. Life would be a lot easier if it were available, if cut with surface would be available at the assembly level, but unfortunately at this point it's not there yet. I've put in an enhancement request, so I hope that's going to come soon. It will make my life a hell of a lot easier. Anyway, so that's how we create these miter cuts. We do that for all the parts. So basically for the gusset here, you create a zero offset for the seat tube, and you create a zero offset for the top tube, and then you miter the gusset that way. So to sum it all up, it's a pretty straightforward process. It takes a bit of work to go through all these, but we create an assembly layout sketch first, then we mate all the parts that we have to the assembly layouts that we've created, and then we use in-context surfacing features to miter the tubes, and you end up with something that looks like this that can actually be used to create a 2D drawing and manufacture the part. Alright, well this was number 3 in our series, and number 4 will be on its way pretty soon.